All right, welcome to Wednesday. We are taking a look at trapezoids. So today we're taking a look at how to prove something's a trapezoid and then how to show its isosceles. Okay, so if we remember back to our notes here, if we want to show something's a trapezoid, okay, we need to get, and there's two definitions we're going to talk about for a trapezoid. One is, and this is one that New York State uses, it just needs two parallel sides. One set of sides parallel makes it a trapezoid, and then you have to get the other set of sides parallel to make it a parallelogram. We're going to go ahead and do the second definition, which is that there's only two parallel sides. So two sides are parallel, two sides aren't. And then the isosceles trapezoid, we're just going to show that the two non-parallel sides, those are called the legs, that those are equal. And we have to use the distance formulas. Remember, parallel slope equal is distance, okay? Then remember the parallel sides are called the bases, non-parallel sides called the legs. So for the first question here, we have our quadrilateral time, and we want to show it's a trapezoid. So I already can see what sides are going to be the same and what aren't in terms of their slopes are going to be parallel. So TI and ME should be the same slope, and then TE and IM. So we're going to do the slope, and we'll start with just TI. So once again, y2, so going to I is 1, minus y1 from t is 3, over x2, which from I is 4, minus x1, which is negative 4. So minus negative 4 becomes positive, and this becomes negative 2 over 8, which simplifies down to negative 1/4. Okay, so the next slope is going to be IM, going around. All right, and that's going to be from M, the y is negative 4, minus the I is negative 1. The x2 from M is 5, minus x1, which is 4. And this is going to become negative 5 over 1, which is just negative 5, but we'll leave it like that. And then the other slope is ME. Now we should know that this is going to be the same as TI, so we want to get negative 1/4. That's going to kind of be our check here that we did it right. Okay, so y2 is negative 1, minus y1, which is a minus negative 4. So that's our double negative, make it a positive. And then we get negative 7 minus 5. So negative 1 plus 4 is 3. Just going to clean that up a minute. So 3. And negative 5 or 7 minus 5 is going to be negative 12. And this is indeed negative 1/4. So this works. Okay, and then the slope for the last one is going to be TE. And so do the same thing here. So starting with E, the y coordinate is negative 1, minus 1 from T, which is 3. And then x2 from E is negative 7, minus 1 from T, which is minus a negative 4. This is going to be plus a positive here. So I'm going to get negative 4 over negative 3, which is positive 4/3. So we have two lines that are parallel, two that are not. So TI is parallel to ME. Okay, and we know that IM is not parallel, but the slash through it. TE. All right. And for this one, we can put down here that the slopes are equal and the slopes are not equal. All right. And so now we can go ahead and make a little summary statement here for part A. So part A, that TIME is a trapezoid since one pair of sides is parallel, right? And then we can put down slopes are equal. Normally I would write this one if we were doing that single statement here. So slopes are happy. All right, so the next one we're going to do is we're going to show that it is isosceles, or it's not isosceles. So these two sides, TE and IM, are going to be not the same distance. Okay, so we're going to make this just a little bit smaller so I can see the coordinates again. All right, and here we go. So we're going to do the distance. So we'll do one distance formula, we'll do one Pythagorean theorem. So the distance of one of the sides we're showing, which is TE, go ahead and do that. So TE, we're going to do x2, so that's coming from E, is -7. -7 minus 1 from T, which is -4 squared, plus the y coordinate from E, which is -1, that's y2, minus y1, which is 3 squared. And so this distance of TE is equal to the square root. So we're going to add the double negative. So this is, once again, going to turn into -3 squared plus -4 squared, which we know is going to be 25, which is going to equal 5. All right, the next one we're going to do is Pythagorean theorem. So we can see we're going to go over 1 here to the right, and then we're going to go down 1, 2, 3, 4, 5. So the slope of IM is going to be rise over run. Oh, we're not doing slope. We're doing distance. But we could do slope that way too. You can count the rise and the run here. But we're doing distance of IM. And so that's a squared plus b squared equals c squared. We're going to use the 1 and the 5. So 1 to the right is 1 squared plus, we're going, now if we're going to the right, then we're going down. So that's going to be -5 squared. Put parentheses around both of these. So this is going to be 26, which is going to be the square root of 26, which is obviously not the same as the square root of 5. And so now we can make our statement. TIME is not CELES cents. And we can say TE is not equal to IM, since distances are not equal. And that's it. Okay, going down the line here to the next question. Number 2. Pretend you don't see that. All right. And here we go. So we have quadrilateral ABCD, which we graphed. We want to show that it is a trapezoid and that it is isosceles. So we're going to go ahead and do our slopes again. So we have our 4 lines. We have AB. Okay. We have the slope of BC, the slope of CD, and the slope of AD. Now, 2 of these are nice and easy. The slope of BC is going to be 0, and the slope of AD is going to be 0. That's a horizontal line, which just has a slope of 0. No real work to be shown. For AB, we're going to go ahead and show that work. So y2 is 5 minus y1, which is 2. Once again, that's 1 from B and then A. And then the x's is 2 minus 1. And so this is 3 over 1, which is just 3. And then the slope of CD. So once again, we're going to start with D. That's 2 minus 5 over 2 minus 5. Oh, yeah. D. So it's CD. 2 minus 5. And then, yeah, 6 minus 1. Remember, this is not supposed to be the same, so don't get caught up if it's not, which I was doing there for a second. All right, so 2 minus 5 turns into -3. And then 6 minus 5 is 1, so this turns into -3. All right, so these slopes are not the same. So we can say BC is parallel to AD. Okay, slopes are equal. And we can also now say that AB is not parallel to CD. Okay, slopes are not equal. And then we can go ahead and make our statement here. Same thing as before. ABCD is a trapezoid since one pair of sides is parallel. And once again, if you want to put that down, you can also add in there that distances are equal. All right, and then we're going to do the distances for those sides. So the two legs, which are supposed to be the same, should be AB and CD. So the distance of AB, so once again, that is x2, so that's 2, minus x1, which is 1 squared, plus y2, which is 5, minus 2 squared, which gives us the square root of 1 squared plus 3 squared, and this is the square root of 10. Now we don't have to simplify this, even if it was bigger. We can just leave it as a square root of 10 and so that we get the exact same thing on the other side. And here we can just use the rise and the run if you would like. So this is plus 1, negative 3, and then a squared plus b squared equals c squared. So 1 squared plus negative 3 squared is equal to c squared. It's consistent there. So 10 is c squared, and then square root of 10 is c. So then the distance of CD is also the square root of 10. And then we're just going to make our statement, and we're good to go. Okay. Scrolling down. So we can say that ABCD is an isosceles trapezoid since the non-parallel, need the forward slashes, are equal or congruent. Okay, and we would just say distances are the same, right, are equal. And that's it. Okay, if you want to make a statement over here that says that AB is equal to CD, feel free. Distances are equal. And then we make our summary statement over here. And that's it, guys. That's it for trapezoids. So once again, showing that something's a trapezoid, we want to get those two parallel sides. Get the other two sides not parallel helps. And then we get the non-parallel sides congruent for the isosceles part. All right, guys, have a great day, and I'll see you tomorrow.